Crop diversity and climate resilience building food security in a changing climate. Agriculture is entering a period of unprecedented change. Around the world, farmers are facing rising temperatures, shifting rainfall patterns, more frequent droughts, floods, storms, and the growing spread of pests and diseases. These environmental changes are affecting agricultural productivity and creating new risks for food systems that support billions of people. Crop diversity and climate resilience building food security At the same time, global food security remains under pressure. Hundreds of millions of people continue to experience hunger, while billions more face varying degrees of food insecurity. As populations grow and climate conditions become increasingly unpredictable, ensuring a stable and reliable food supply has become one of the defining challenges of the 21st century. Modern agriculture depends heavily on a relatively small number of crops. Rice, wheat, and maize provide a large share of the calories consumed worldwide. While these crops have helped feed a growing global population, dependence on a limited number of species also creates vulnerability. When environmental conditions change or new biological threats emerge, entire production systems can be placed at risk. One of nature's most powerful responses to uncertainty is diversity. Throughout history, farmers and communities have cultivated thousands of crop species and countless varieties adapted to different climates, soils, cultures, and growing conditions. This diversity represents a vast reservoir of genetic resources that can help agriculture adapt to changing environments. Crop diversity includes the variety of crop species we cultivate. The diversity found within each crop species, traditional farmer-developed landraces, and the wild relatives from which many crops originated. Together, these forms of diversity provide the biological foundation for resilience, adaptation, and long-term food security. In this module, we will explore how crop diversity strengthens agricultural systems, reduces vulnerability to climate-related shocks, supports stable food production, and contributes to resilient food systems capable of meeting future challenges. We will examine the scientific evidence, the role of genetic diversity, the importance of conservation, and the practical strategies being used around the world to build climate-resilient agriculture. Understanding crop diversity is not simply about understanding plants. It is about understanding how biodiversity, agriculture, climate adaptation, food security, and human well-being are interconnected within a complex and rapidly changing world. We will examine diversity at multiple levels, including diversity among crop species, diversity within crop species, traditional farmer-developed varieties known as landraces, and the wild relatives that contribute valuable genetic traits to modern agriculture. You will also learn how climate change affects agricultural systems. Rising temperatures, changing rainfall patterns, extreme weather events, and expanding pest and disease pressures are transforming growing conditions around the world. Understanding these pressures is essential for understanding why resilient agricultural systems are becoming increasingly important. A central theme of this module is the relationship between diversity and resilience. We will explore how biological diversity helps agricultural systems absorb shocks, adapt to changing conditions, and continue functioning even when individual crops or varieties face environmental stress. You will also examine how crop diversity contributes to food security. Diverse agricultural systems can help stabilize production, reduce risk, improve nutrition, and support the livelihoods of farming communities. In a world facing increasing uncertainty, diversity acts as a form of biological insurance that helps safeguard food supplies. Another important objective is understanding the conservation of genetic resources. We will explore why protecting crop varieties, traditional landraces, seed collections, and wild relatives is essential for future agricultural adaptation. These resources provide the raw genetic material needed to develop crops capable of thriving under changing climatic conditions. Finally, we will apply systems thinking to agriculture and climate adaptation. Rather than viewing crops, farmers, ecosystems, and food systems as separate components, we will examine how they interact within a larger system. This perspective helps reveal how decisions made today can influence resilience, sustainability, and food security for future generations. As we move through the module, keep these learning objectives in mind. Together, they provide a framework for understanding how crop diversity supports resilient agriculture and why it is increasingly recognized as a critical component of climate adaptation strategies worldwide. Before we begin exploring the science of crop diversity and climate resilience, it is useful to understand what this module aims to accomplish. Climate change is creating complex challenges for agriculture, food systems, and rural livelihoods. Addressing these challenges requires more than simply understanding individual crops or farming practices. It requires an appreciation of how biological diversity contributes to adaptation, resilience, and long-term sustainability. By the end of this module, you will be able to explain what crop diversity is and why it matters. Crop diversity is one of the most important yet often overlooked foundations of global food security. For thousands of years, farmers have cultivated a wide range of crops and crop varieties adapted to different climates, soils, landscapes, and cultural traditions. This diversity has enabled agriculture to thrive across an extraordinary range of environmental conditions and has provided humanity with the biological resources needed to adapt to change. Today, however, agriculture faces growing challenges. Climate change is increasing temperatures, altering rainfall patterns, intensifying droughts and floods, and expanding the range of pests and diseases. These changes are creating new risks for agricultural production at a time when global demand for food continues to rise. Modern food systems also depend heavily on a relatively small number of crops. Rice, wheat, and maize provide a significant share of the world's food supply. While these crops are essential to global nutrition, dependence on a limited number of species and varieties can increase vulnerability when environmental conditions become unstable. Crop diversity helps reduce this vulnerability. Agricultural systems that contain a wider range of crops and crop varieties are generally more resilient to climatic shocks. Different crops respond differently to environmental stress. When drought, heat, flooding, or disease affects one crop, others may continue to perform well, helping to stabilize production and reduce overall risk. The benefits of crop diversity extend beyond production stability. Diverse agricultural systems often support healthier soils, more effective pest management, greater biodiversity, improved resource efficiency, and more nutritious diets. These benefits strengthen both ecological and social resilience. At the genetic level, diversity provides the raw material for adaptation. Traits such as drought tolerance, heat tolerance, salinity tolerance, flood resistance, and disease resistance are often found within traditional crop varieties and wild relatives. Plant breeders depend upon these genetic resources to develop improved varieties capable of thriving under changing environmental conditions. The conservation of crop diversity has therefore become a global priority. Seed banks, gene banks, botanical collections, research institutions, farming communities, and international organizations are working together to preserve and utilize genetic resources before they are lost through genetic erosion. Protecting this diversity helps ensure that future generations will have access to the biological tools needed to respond to emerging challenges. Research from around the world increasingly demonstrates that crop diversification can strengthen agricultural resilience. Diverse farming systems often experience lower production variability, improved recovery following environmental shocks, and greater capacity to adapt to uncertain future conditions. While crop diversity is not a complete solution to climate change, it represents an important component of broader adaptation and food security strategies. This module explores how crop diversity contributes to climate resilience, examines the scientific evidence supporting diversification, and highlights the role of genetic resources in building sustainable food systems. The central message is straightforward but powerful. Diversity increases options, and in a world characterized by uncertainty, options create resilience. As climate change accelerates and agricultural systems face mounting pressures, preserving and utilizing crop diversity may prove to be one of humanity's most valuable investments in food security, sustainability, and long-term well-being. While the Stanford study demonstrated that crop diversity can help buffer the effects of climate change, change, it is not the only body of evidence supporting diversification. Researchers across the world have been investigating whether agricultural diversity contributes not only to production stability, but also to broader social, economic, and environmental resilience. One of the most significant contributions to this field comes from CGIAR, the world's largest global agricultural research partnership. CGIAR works with research centers, governments, universities, and farming communities across many countries, particularly in regions where agriculture is highly vulnerable to climate change and food insecurity. In recent years, CGIAR researchers have examined how crop diversification influences the resilience of farming households and rural communities. Their work focused on a simple but important question: can increasing crop diversity help farmers adapt to climate change while simultaneously improving livelihoods and food security? To answer this question, researchers reviewed a large body of scientific literature and practical experience from around the world. The analysis examined studies conducted between 2015 and 2020 and evaluated the impacts of crop diversification across a wide range of agricultural systems and environmental conditions. The findings were encouraging. The review found substantial evidence that crop diversification can generate multiple positive outcomes for farming communities. Farmers adopting diversification strategies often experience improved yields, increased household incomes, better nutrition, enhanced food security, and access to new market opportunities. These benefits were observed across different geographic regions and production systems. One reason for these positive outcomes is that diversification creates multiple sources of production and income. Instead of depending entirely on a single crop, farmers cultivate a portfolio of crops that perform differently under varying environmental and market conditions. This reduces dependence on any one source of livelihood and increases overall stability. The research also found that diversified systems can contribute to poverty reduction. By broadening production opportunities and reducing vulnerability to crop failures, diversification can strengthen household economic security. This is particularly important for smallholder farmers who often operate under highly uncertain conditions. Nutrition emerged as another important benefit. Agricultural systems dominated by a narrow range of crops may produce large quantities of calories, but may not necessarily provide balanced nutrition. Diversified farming systems often include a wider variety of fruits, vegetables, legumes, grains, and other foods that contribute essential vitamins, minerals, and nutrients. As a result, diversification can improve both food availability and dietary quality. The CGIAR review also highlighted an often overlooked benefit: enhanced adaptive capacity. Farmers who manage diverse systems frequently develop broader knowledge, greater flexibility, and increased ability to respond to changing conditions. Diversity creates opportunities for experimentation, innovation, and learning, all of which contribute to long-term resilience. An interesting concept emerging from the research is ecological redundancy. This refers to the presence of multiple species or varieties capable of performing similar functions within a system. If one crop or variety fails, others may continue to provide food, income, or ecological services. This redundancy reduces the risk of complete system failure and strengthens resilience under stress. However, the CGIAR researchers also identified an important challenge. While evidence clearly demonstrated positive effects on yields, incomes, nutrition, and adaptive capacity, measuring resilience itself proved more difficult. Resilience is a complex concept involving the ability to absorb shocks, adapt to change, recover from disturbances, and continue functioning over time. Quantifying these attributes in real-world farming systems remains challenging. As a result, the researchers emphasized the need for more refined methods to evaluate resilience and to help farmers make informed diversification decisions. They proposed clearer frameworks for understanding how diversification contributes to long-term adaptation and sustainability. Perhaps the most important conclusion from the CGIAR work is that crop diversification should not be viewed solely as an agricultural practice. It should be understood as part of a broader transition toward more sustainable and resilient food systems. Diversification affects not only crops but also livelihoods, nutrition, ecological stability, community resilience, and long-term sustainability. Its benefits extend beyond individual farms and influence entire agricultural landscapes and food systems. The research reinforces a recurring theme throughout this module. Diversity creates resilience by creating options. The more options available to farmers and communities, the better equipped they are to respond to uncertainty. As climate change increases environmental variability and agricultural risks, these findings become increasingly relevant. Diversification offers a practical pathway for strengthening resilience while simultaneously supporting productivity, food security, and sustainable development. The evidence from CGIAR therefore complements the findings from Stanford and other research institutions. Together, they suggest that crop diversification is not simply an ecological principle. It is a practical adaptation strategy with measurable benefits for people, agriculture, and the environment. In the next section, we will explore the biological foundation that makes these benefits possible. Genetic diversity, nature's own mechanism for adaptation and resilience. One of the most practical and widely used forms of agricultural diversification is crop rotation. Crop rotation refers to the practice of growing different crops on the same field over a sequence of growing seasons. Rather than planting the same crop year after year, farmers alternate among crops with different biological characteristics, nutrient requirements, rooting patterns, and ecological functions. Although the concept is ancient, modern research increasingly shows that crop rotations remain one of the most effective tools for improving agricultural resilience, sustainability, and long-term productivity. To understand why crop rotations matter, consider what happens in a continuous monoculture system. When the same crop is grown repeatedly on the same land, pests, diseases, and weeds that specialize on that crop often accumulate over time. Nutrient demands become repetitive, soil structure may deteriorate, and dependence on external inputs such as fertilizers and pesticides can increase. Crop rotations help break these cycles. Different crops interact with the soil and surrounding ecosystem in different ways. A crop that hosts certain pests may be followed by a crop that those pests cannot utilize. A crop with shallow roots may be followed by one with deeper roots that accesses nutrients and water from lower soil layers. Legumes may be introduced into rotations to naturally add nitrogen to the soil. These ecological interactions create healthier and more balanced agricultural systems. Crop rotations also contribute to soil health. Different crops leave different residues, influence microbial communities in different ways, and affect soil structure through their root systems. Over time, diversified rotations can improve soil organic matter, water infiltration, nutrient cycling, and overall soil fertility. Healthy soils are particularly important under climate change. Soils with higher organic matter can often retain more water during droughts, while also improving drainage during periods of excessive rainfall. This buffering capacity helps reduce vulnerability to climate extremes and contributes to greater production stability. One of the most important pieces of evidence supporting crop rotation comes from long-term agricultural studies conducted across North America. Researchers examined extensive data sets covering different climatic regions and farming systems to determine whether diversification through crop rotations could improve resilience under adverse growing conditions. The findings were remarkable. The study found that more diverse crop rotations consistently increased maize yields across a wide range of environmental conditions. On average, diversified rotations produced higher yields than less diverse systems, even under favorable growing conditions. This challenges the common assumption that diversification necessarily requires sacrificing productivity. Perhaps even more importantly, the benefits became especially apparent during difficult years. Under unfavorable growing conditions, including drought years, diversified crop rotations significantly reduced yield losses. In some cases, the reduction in drought-related losses was dramatic, demonstrating that diversified systems were better able to withstand environmental stress and maintain production. This finding is highly relevant in the context of climate change. Future agricultural systems are expected to face increasing climatic variability. farmers will likely encounter more frequent droughts, heat waves, intense rainfall events, and other environmental stresses. Agricultural practices that improve resilience under adverse conditions therefore become increasingly valuable. Crop rotations achieve this resilience through multiple mechanisms. They reduce pest and disease pressures, they improve soil health and water management, they diversify biological processes within the farming system. They spread production risks across different crops and growing seasons, and they create greater flexibility in responding to changing environmental conditions. An additional benefit is that crop rotations often reduce dependence on external inputs. Improved nutrient cycling can lower fertilizer requirements. Better pest management may reduce pesticide use. Enhanced soil health can improve resource efficiency and reduce production costs over time. These advantages contribute not only to environmental sustainability, but also to economic resilience. For farmers, resilience is not solely about surviving environmental shocks. It is also about maintaining profitability and long-term viability. Practices that improve both ecological and economic performance are therefore especially valuable. Crop rotations demonstrate an important principle that appears repeatedly throughout this module. Diversity and productivity are not necessarily competing objectives. For many years, agricultural discussions often framed productivity and diversity as opposing goals. The evidence increasingly suggests a different perspective. Under many circumstances, diversity can enhance productivity, stability, and resilience simultaneously. In essence, crop rotations transform diversity into a practical management tool. They take the concept of diversification and apply it directly within the farming system, producing measurable benefits for soils, crops, farmers, and ecosystems. As climate uncertainty grows, strategies such as crop rotation are likely to play an increasingly important role in helping agriculture adapt to changing conditions. The broader lesson is clear. Diversity does not simply exist in nature, it can also be actively managed. Through thoughtful agricultural practices, farmers can harness the power of diversity to build systems that are more productive, more resilient, and better prepared for the challenges of the future. Before we continue, take a moment to reflect on what we have discussed so far. Throughout this module, we have explored the growing challenges facing global food systems. We have seen how climate change is increasing environmental uncertainty through rising temperatures, changing rainfall patterns, droughts, floods, storms, and other extreme weather events. We have also examined how crop diversity can help agricultural systems manage risk and improve resilience. Now consider the following question. If you were a farmer operating in a region experiencing increasing climate variability, would you choose to rely on a single crop and a single variety? Or would you prefer to cultivate a more diverse portfolio of crops and varieties? There is no single correct answer, but the question encourages us to think about the relationship between efficiency and resilience. Specialized agricultural systems can often be highly productive under stable conditions. They may benefit from economies of scale, standardized management practices, and well-developed markets. However, they may also become more vulnerable when environmental conditions change unexpectedly. Diversified systems, on the other hand, spread risk across multiple crops and varieties. While they may require more complex management, they often provide greater flexibility when faced with droughts, floods, pest outbreaks, diseases, or market fluctuations. As you reflect on this question, consider the factors that might influence your decision. How predictable is the local climate? How severe are weather-related risks? How dependent are you on a single source of income? How important is long-term stability compared with short-term productivity? What role does uncertainty play in your decision-making? These are not only questions for farmers, they are also questions for policymakers, researchers, businesses, and communities seeking to build resilient food systems. One of the key lessons emerging from climate adaptation research is that resilience often involves maintaining options. Diversity creates those options by providing multiple pathways for responding to change. As you think about your answer, consider how the concept of biological diversity functions much like insurance. It may not eliminate risk, but it can reduce vulnerability and increase the ability to recover from unexpected events. Take a few moments to reflect on your own perspective before moving to the next section, where we will examine the biological foundation that makes adaptation possible: genetic diversity. Question 1. Which major research institution found that crop diversity can help buffer agricultural systems against climate variability? A. NASA, B. Stanford University, C. World Bank, D. OECD. Correct answer: B. Stanford University. Research found that diversified agricultural systems often demonstrate greater stability and resilience under changing environmental conditions. Question 2. What important benefit was identified in CGIAR's review of crop diversification? A. Elimination of climate risk. B. Improved yields, nutrition, and adaptive capacity. C. Replacement of traditional farming systems. D. Reduced biodiversity. Correct answer: B. Improved yields, nutrition, and adaptive capacity. Diversification creates multiple production opportunities and strengthens resilience. Question 3. Why can crop rotations improve resilience? A. They increase dependence on one crop. B. They help break pest, disease, and soil degradation cycles. C. They eliminate drought. D. They prevent all yield losses. Correct answer: B. Crop rotations help break pest, disease, and soil degradation cycles while improving soil health. A region depends heavily on a single cash crop. Climate variability increases, a pest outbreak occurs, and market prices decline. How might diversification have reduced the impact on farmers and food systems? Possible responses include diversification of crops, broader income sources, greater genetic diversity, improved soil health, and stronger adaptive capacity. Diversity spreads risk across biological, economic, and environmental dimensions. Research increasingly supports diversification as a resilience strategy. CGIAR studies demonstrate benefits for livelihoods, nutrition, and adaptation. Crop rotations improve productivity and resilience. Diversity reduces risk and strengthens recovery capacity. Next lesson: genetic diversity and adaptation.